Hello students, welcome to Sorcerer's classes. Now in the previous video on real analysis we had done Cauchy's second theorem, right? Cauchy's second theorem. Actually I had showed you an example. Okay, I showed you an example on the Cauchy's second theorem. Now we are here in this video to prove that the Cauchy's second theorem may not be true. So let's just write the theorem. What was Cauchy's second theorem? So Cauchy's second theorem said that limit n tends to infinity an whole to the power 1 by n is equal to limit n tends to infinity a n plus 1 divided by a n, provided, what is provided? The RHL or the right hand limit exists, right? So this was Cauchy's second theorem on limits, of course. Okay, so now what we are going to say, let's put it on a note. If a sequence an is taken, then limit n tends to infinity, okay, n tends to infinity a of n 1 by n, we have but limit n tends to infinity a n plus 1 by a n may not exist. That means the right hand limit may not exist, although this left hand part will exist, but the right hand limit may not exist. Okay, so I got a very nice example to show you on this, so concentrate. I'll show you an example how this is happening. Okay, so example, let us take an to be this 2 to the power minus n plus minus 1 whole to the power n, correct? So what is an plus 1? An plus 1 is 2 minus n plus 1 plus minus 1 whole to the power n plus 1. Now let's find the limit of the left hand side. So limit n tends to infinity an whole to the power 1 by n will be written as 2 to the power minus n plus minus 1 whole to the power n, whole thing to the power minus whole thing to the power 1 by n. So what does an now become? An becomes, let's go a little up because I need to see that. An now becomes 2 to the power minus n divided by n, right, plus minus 1 whole to the power n. So this whole thing is actually divided by n, so let's write the n in the middle. Okay, like this it is. So eventually 2 to the power minus 1 you have, plus minus 1 to the power n, this one divided by n. Okay, so that is limit n tends to infinity an whole to the power 1 by n. Alright, so when you see this, that as n tends to infinity, this part is 0, correct? As n tends to infinity, this part is 0. So what is this? this is equal to 1 by 2. Okay, so limit n tends to infinity, an whole to the power 1 by n exists. Alright, let's go ahead and prove that the right hand side may not exist. Okay, so but an plus 1 divided by an will be equal to, so let's copy an plus 1. An plus 1 is 2 to the power minus n plus 1, so this is 2 to the power minus n plus 1 plus minus 1 to the power n plus 1, whole thing divided by 2 to the power minus n plus minus 1 whole to the power n. So this is 1 whole power, putting it in square brackets. Okay, just let's rub that out. Looks like an e, but that's a negative n. Okay, and this is the whole thing also with the power. So same basis, powers are, when same bases are divided, powers are subtracted. So 2 to the power, let's go a little down, 2 to the power minus n plus 1 plus minus 1 whole to the power n plus 1 plus n minus minus 1 whole to the power n. Correct? Okay. So now from here what do we have? We have 2 to the power minus n minus 1 plus minus 1 to the power n plus 1 plus n minus minus 1 to the power n. Positive, negative, gone away. So eventually you are left with 2 to the power minus 1 plus minus 1 n plus 1 minus minus 1 to the power n. Correct? So you can further solve this, but there is no need actually. There is no need, just write it as an plus 1 divided by an. Now if you notice on what's happening over here, if you notice that when I take, when n is equal to 2, suppose even number if I take, then an plus 1 by an will be 2 to the power minus 1 plus minus 1, 2 plus 1 minus minus 1 to the power 2. So this is a negative 1 over here, so that becomes, see, so that becomes equal to 2 to the power minus 1 plus minus 1 minus 1. Correct? So that is 2 to the power minus 3, that is 1 by 8. So a2 by a1 actually, not an, a1. I'm going to change that to a1. So n was 2, right? So this is 3. Okay, and this will be, this is 3 and this is a2. Okay, so you can you see that it's coming even, it's coming 1 by 8 when even. Okay, and when you put an odd number, so say you put 1, when n is equal to 1, then what do we have? A1 plus 1 divided by a1 is equal to, what is that? 2 to the power minus 1. So 2 to the power minus 1 plus minus 1 to the power, what was an plus 1? N plus 1, right? yeah, n plus 1 that was. So minus 1 to the power 1 plus 1, of course. Then what was it? I have to check it every time. Then that is minus, okay, and that's a minus 1 to the power 1. So what are we left with? We are left with just 1 by 2, okay, a2 by an. So what can you understand from here? We are getting two things, right? Look at this. For a n plus 1 by a n, we write it's coming 1 by 8 when n is even, and 1 by 2 when n is odd. So limit n tends to infinity, a n plus 1 by a n doesn't exist. Okay, so what did you understand from here? That this part exists, this part exists, okay, this part definitely exists, but the an plus 1 by an doesn't exist. Understood? This part doesn't exist. Whereas what was the second theorem of Cauchy saying? Second theorem of Cauchy was saying that if the top part, this red part exists, okay, then no, if the right hand side exists, it's written here only on top. So provided that it's written over here, provided that RHL exists, okay, provided that RHL exists, this will be equal to each other, provided that RHL will exist, okay. But the converse of the second theorem says that the left hand side, the an part whole to the power 1 by n may exist, but the right hand side may not exist, okay. So it doesn't matter if the left hand side exists, but the right hand side may not exist. So this was the second converse of the second theorem, okay. So please check it out. So this we have means this exists, okay. If a sequence is given an and this is how it's taken, then we have this sequence, but this one may not exist. We have means it exists, okay. That's what I try to write over there. So this may not exist, okay. So this is the example how something is existing and something is not existing, okay. Now let's just write one or two notes on this, okay. Note down, these are a few notes I'm giving you. This is the first note. Note 1. It says that if an is greater than 0 and limit n tends to infinity, an is equal to L, then limit n tends to infinity, a1 dot a2 dot a3 dot right until an whole to the power 1 by n is equal to L as well, okay. Alright, this is the first note. Second note won't give you many notes for today, okay. We'll have to continue on to the next video. So the second note says that if limit n tends to infinity, a n plus 1 by an is equal to some limit point L where mod of L is less than 1, okay, then limit n tends to infinity, an is equal to 0. Alright, so today what we have done in this video, we have done about the Cauchy's second theorem, okay, and we said that the second theorem may not be true also, because the right hand side may not exist, the limit right hand side may not exist, okay, and then I showed you with a proof how the right hand side is not existing, okay, whereas the left hand side is existing, right? Here's the left hand side, it is existing. You can see over here the left hand side is existing. Let me just highlight it for you. Yeah, this is the left hand side, right? It's becoming what? Becoming half, right? Okay, so it exists, but this is not existing because these are coming, they are coming different values, okay, so it's not existing, okay. So that's it then for today. You keep taking as much help as possible, because all the help that you need will be provided at Saurabh Sir's classes. Thank you for watching.